In this worked example, we'll be looking at the diffraction grating equation. So this is question 29 from the March 2019 paper 1. I think it's paper 12, actually. It says a diffraction grating experiment is set up using orange light of wavelength 600 nanometers. The grating has slit separation of 2 micrometers. Let's go ahead and label some of this. And so the wavelength is lambda, and I want to rewrite 600 nanometers as, you can do it like this, 600, and remember that nano is 10 to the negative 9, or you could say, oh, well, that's the same as 6 by 10 to the negative 7, because maybe you're mindful that all of the visible parts of the spectrum are on the order of 10 to the negative 7 meters, right? So it's either 600 by 10 to the negative 9, you sort of take those 2 orders of magnitude from here, or it's just 6 by 10 to the negative 7. So both of these are correct for this wavelength. The grating has a slit separation. So remember that the distance between the slits in a diffraction grating is what we call d, and it's 2 micrometers, okay? The equation that's important here is d sine theta. So remember, like design. Oh, d sine, design. We design the equation for diffraction gratings. D sine theta equals n lambda, right? Where n is the order number. So here we've got like the first order and the second order. So those are like some given information too. It's asking us to calculate theta twice and then take the difference. And so once you kind of lay everything out like that, you say, well, that's not so bad. Just plug everything in and kind of solve it. So let's solve it like this. Sine theta 1 is going to be equal to, well, that's when n would be 1, right? So like that first order, so I'll just say like n is 1. Lambda for both of these is 6 by 10 to the negative 7. And what I've done is divided each side by d. So I'm dividing each side by 2 by 10 to the negative 6. So now I know the sine of theta 1, this angle here to the first order is going to be 6 by 10 to the negative 7 divided by 2 by 10 to the negative 6. And so it's at 3 by 10 to the negative 7 minus negative 6 plus positive negative 1. 3 by 10 to the negative 1. Is that good mental math, class? Or I get a calculator, huh? Six by 10 to the negative 7 divided by 2 by 10 to the negative 6. Yeah, 3 by 10 to the negative 1. That's right. So for this one, the first order, if the sine of theta 1 is 0.3, then theta 1 must be the inverse sine of 0.3. And so I'm going to take the inverse sine, and that's 17.46, 17.5. And if you're so happy that you got that answer and you see it here and choose it, you're wrong. You forgot to calculate the separation between them. I mean, they really didn't even have to give you this. They could have said, what is the angular separation? For them, like friendly enough to say, hey, that's the difference between them. Excuse me. Now we got to look at theta 2, right? What's going to be the difference there? It's the same diffraction grating. It's the same orange light. The difference is this 1 here becomes a 2, and that means we're solving for theta 2 now. So now it's just going to be, I guess those 2's will cancel. It's going to be what? 6 by 10 to the negative 1. It's going to be twice, right? Let's just make sure. We're doubling it, right? Like we added a 2 there, so it's like 2 times 6 by 10 to the negative 7. Divided by 2 by 10 to the, yep, 0.6. So the sine of theta 2 is 0.6, right? Quite much, because we just doubled the order. So that means we're going to take the inverse sine of that, and we got 36.86. 2, and then we'll take the difference between them. And again, like 36.9 is also an answer choice, okay? I guess if you add them, you'll maybe get this one. So people are like, made it as far as this, they got the 2 angles, but then they blew it on a, it's like, oh, I should have subtracted. So I'm pretty sure B is the answer, right? So it's 36.86 minus 17.46, 19.4. So B is the correct answer. See how these answers show up though, because they're what you calculate along the way. And if you just completely were like, I'm running out of time, I don't have time to reread the question, maybe I'll just add them, 36.86 plus 17.46, 54.3, and you didn't correct it. It's like, I don't know how, you know, it's kind of like, I don't like 100%. I know I've answered every other question on the physics exam right, and I'm just going to choose this because, you know, I want to choose the joke answer. I don't know. So yeah, it's asking for the, I mean, it's right there, minus, okay? So you wouldn't add them. Right, so B is correct. And that's how we solve problems involving multiple slit interference, answering the essential question of the day.